Hi, my name is Ryan Booz. I'm a solutions engineer here at pganalyze, and today I'd like to begin episode 5 of our deep dive series into pgstat statements, specifically talking about configuration of this extension. Now, in the first 4 episodes, we've talked about what pgstat statements is, the kind of metrics that it stores, how those query texts are normalized, and where those texts are actually stored on disk in a file. And in the last episode, we actually went through the entire process that takes place in order to store new incoming metrics about the queries that are being executed. We've seen a lot of value from pgstat statements. It is our main primary view into what's happening with completed query executions. But we've also discussed one of the major issues that some people are unaware of when it comes to analyzing this data, and that is deallocations. In order to store all the information coming in, sometimes pgstat statements has to remove previously stored data in order to make room for new information. And one of the settings in pgstat statements determines how often and when the extension will do that. Now, if you're not tracking the information through the pgstat statements _info view, then you are not really aware of how much information you could be losing over time. In this example screenshot, since this server has started or the stats are reset, we have deallocated 46 times. On this example server, the default max setting is used. That means 250 rows have been dropped from that table 46 times since this server began. Now, if you aren't tracking it, maybe your tool is. In pganalyze, we actually do show this to you over a 10-minute window. And so we have a counter for each server that we're tracking. In this example, over a 10-minute window, this server deallocated rows 2 times. And again, this is set to the default of pgstat_statements.max of 5,000. So that means approximately every 5 minutes, 250 rows of metrics were deallocated to make room for new incoming statement metrics. Taking a sample of the deallocation counter is actually pretty easy and something you should do on a periodic basis. You simply query pgstat statements _info and you'll get the deallocation counter. And the 10-minute window is just a good time frame because it makes division easier to understand on a per second basis how often this is happening. So if there's no change over that 10-minute window, you query the view and 10 minutes later you query it again and the dealloc counter has not gone up, you're honestly in a pretty good state. Most reasonable monitoring tools should be querying pgstat statements at least once every 10 minutes. And so you're most likely retaining as much data as you can. Now, if the counter goes up by about 10, then that means about every minute you're losing 5% of the rows from that hash table. This is a little concerning, especially if your monitoring tool is not querying that data frequently enough. Now, once you reach about 100 deallocations per 10 minutes, that means every 6 seconds or so, you are losing 5% of your rows. That's a lot of contention. This is really, really concerning. And then believe it or not, I have seen numbers at 600 plus. Consider that. If you have 600 deallocations every 10 minutes, that means approximately every second, pgstat statements is trying to deallocate enough rows to make room for new incoming information. That is a lot of locking and effort on your metrics table, and it means you're very likely losing information that could be helpful to tuning your database. So let's go ahead and talk about the configuration settings of pgstat statements. This comes straight out of the Postgres documentation and is something that you can go look at yourself. First and foremost is pgstat statements max. Now, we've talked about this setting often in every video thus far, and so I won't spend much time here. The 2 things I want to mention are that a restart is required. Now, we've talked about this a few times, but if you decide that you want to raise this value because you have a lot of deallocations, you will have to plan downtime for it. There is no workaround for that. So this can be a concern if you are currently having a problem. And then the other thing to recognize is even if you happen to turn off tracking, if the extension is loaded, it will reserve enough memory based on the max count. There's a set schema, and so it understands how much memory it needs to reserve in order to track the maximum number of rows. And so that memory will be taken in shared memory. It's often not that much, a few megabytes or tens at best, but it will be tracked, and that comes straight out of the documentation, just so you understand that. Next is pgstat statements.track. Now, this value can be changed through a simple configuration reload. It has three options that we've talked about previously. By default, it is set to top, and that means it will only track those top-level queries. All will track queries inside of functions and stored procedures as well, and none will turn off tracking. So you can have the extension loaded, but not tracking something. And this is actually a good shortcut if something is going on and pgstat statements might be causing locking issues because there's so much churn. You can quickly change this to none with a reload to stop tracking for a period of time. Setting to all will likely increase the number of rows, which makes sense. And remember, if you do track all, there is no correlation between the non-top level queries and the top level function that called them. Just something to remember. The next one is track utility. This can be changed through a configuration reload as well. No restart is required. By default, it is on, and that means it tracks essentially all the statements that are happening within your database. Even things like prepare, commits, rollbacks, those specific individual statements are tracked, which are taking up space within your database. So if your main priority is to track the DML operations on your database, things like select, insert, update, delete, and merge, then you can turn off track utility and often save some rows that are being written into pgstat statements currently. So when you're in a bind, if you really don't need them, you can set track utility to off and do a reload to get instant relief. Then we have track planning. This also can be changed through a reload. It's something we talked about in one of the previous videos, and it simply adds planning values to your statements. The default is off because it does incur additional overhead because we're dealing with timing issues during that planning phase. And last but not least is the save configuration variable. Now this one, like Max, can only be changed through a restart. It saves the statistics on a normal shutdown out to a file so that it can be reloaded when the server restarts. The default's on. Quite honestly, it's probably what you want. It's nice if you have to restart the server that pgstat statement starts from where it left off, so it doesn't have to reload all those statistics over a period of time. Now, if you're having a lot of deallocations, reducing them through settings comes through two ways. One is by raising pgstat statements.max. We often recommend starting at about 10,000 rather than the default 5,000. This is often a good setting if you have one primary server with one application database. Again, the more databases you have, the fewer slots there are in pgstat statements for each database, and that setting might need to be higher. You can track your deallocations, maybe use that 10-minute window we talked about earlier, and get a sense for how often every minute or every 10 minutes deallocations are occurring compared to the setting. And remember, deallocations indicate 5% of whatever that value is. Once you think you need to get beyond, say, 50 to 100,000 entries in pgstat statements, likely you do have to deal with some other mitigation efforts, the things we'll talk about in just a second. And then you can turn off track utility. This is often a good, cheap way to reduce the number of entries while still retaining the information that you really want to look at when it comes to tuning your application queries. But remember, the fix to deallocations is almost never just about tuning these values in pgstat statements. It is also about looking at your application itself. And so we've talked about a few of these before. The first way you can reduce deallocations is to reduce the uniqueness of the queries that are being executed. Now, one thing we specifically looked at in the first video was the where in clauses, and how when you have many of those with different lengths of values, you get many individual entries in pgstat statements on Postgres 17 and below. Consider how you could change that to maybe an array value, and if you're using an ORM, there might be some helper functions to do that. Any queries that you are generating through concatenation is another place you can look for reducing the uniqueness from query to query. Second, you can reduce the number of databases per server. Because the pgstat statements.max value is a server-wide value, if you have lots of activity across many databases, they're all contending for spots inside of pgstat statements. So you might need to, at some point, begin to break off and have more servers with fewer databases. And finally, make sure that your applications aren't querying the databases with multiple roles if it's not necessary. Again, the same exact SQL statement executed by multiple roles will produce individual statements inside of pgstat statements. And so we're trying to reduce those things. So those are the 5 simple configuration values that you can change within pgstat statements with the goal of reducing deallocations. In the next episode, we're going to talk about those high cardinality workloads and specifically look at a couple of ways that you can minimize the deallocation and the loss of data over time. Hope to see you back as we get close to finishing this series on pgstat statements.